Welcome to the Machine Learning at Home. Today I will show you what is self-training. So self-training is not exactly a machine learning. It's a related method which allows you to use a whole data for training by itself. So it could be useful in several situations, and I will show you how to do it. So first of all, let us load two libraries which we already know how to operate with. MASS and RPart. Since we do not need a training subset, we will use a whole iris data today. So we simply make two models based on a whole data set of iris, on whole 150 cases. So iris.r will be RPart species against all other variables, and data will be the whole iris data. Okay, and then analogously we'll make this LZA model. Okay, so now we'll make predictions based on each of these models. Predict from the model. And for the new data, we use the same data, but without the species character, because we want to predict it. So -5, of course. And now we'll make analogously prediction from LDA. Okay, and now let us look what's going on with our misclassification tables. So we compare iris species, the fifth column of initial data, and for example we compare iris PRED.LZA class. What is going on would be visible. Okay, so it is not an absolutely perfect prediction. Of course, it is slightly better than prediction based on a training group, because in that case we use a whole data set for training. Only 3 cases are misplaced. And now we need to see what's going on with RPart. So for that I will slightly correct our prediction one, because I forgot I need to specify type class here. Okay, and now we can make the same table but for our part function without class, this one. This is slightly worse. As you see, it wasn't very much improved. 6 cases are misplaced in that case. So why do we need it? Well, first idea which comes into the mind is that we might save it for the future in case when we obtain some fresh data where species labels are really truly unknown. The second one, and more important on my view, is to use some particular features of both models. For example, we know that RPart will give you variable importances. So very important, of course, thing when you want to select good variables from multiple variables. So here are only 4 variables, but still interesting to look at. So iris.r, we need a model. And then we need the object variable importance. So I simply type it VA and then press a tab. You can see that petal width is probably the most important variable. And if you remember in our lesson about median learning, we found it like manually. But here you can find it programmatically. Petal width is most important, and next one is a petal length. And from LZA, we have another interesting feature. So if you take the prediction object, we can obtain posterior probabilities and find out which cases were not placed very well. So for example, we need to take the object PRED LDA and then have this posterior component. It's a big table, so we'll select like rows from 60s to 70s, and it will be long numbers, so we should round them with 3 digits, for example. So you can see that, for example, row number 64, row number 67, and especially row number 69 are less well predicted than others, so it will simply tell us about our objects and we can use it to work with our objects. So you see, our part allows us to use variables, work with variables. LDA allows us to use an approach from cases, work with cases. This is why self-training might be useful. There are also multiple other outcomes of self-training. So that was a self-training today. Thank you very much.